What you just learned was how to do orbital diagrams and electron configuration. Now, instead of having to memorize that order, 1s, 2s, 2p, 3s, and so on, I'm going to show you an easier way to read it straight off the periodic table. So what I have here is a blank periodic table, and if you've noticed, I've already outlined the blocks. In the blue is the S block, in the green is the P block, and in the red is the D block. Remember that I have ignored helium. Sorry about that. I have ignored helium and moved it over into the S block, which is where we know that it fits. Now, what we're going to do in order to read off the periodic table, I'm going to show you how we start to view this. And I'm going to start by filling in the letters here, in the numbers. So I've moved helium over, and what I've done here first is I've labeled on the side the energy levels. So I have the first energy level, second, third, fourth, fifth, sixth, and seventh. Now, one thing I did want to point out is that I don't have anything labeled in the F block. You are not going to be responsible for knowing electron configurations into the F block. Okay, so I'm going to stop it at some point when it would go down to the F block, and then we're going to be done. So what I've done up here, you should know by now from those ChemQuest that large number in front, if I'm looking at that 1s1, that large number in front is the energy level. The S tells me what sublevel it's in, and the little subscript 1 tells me how many electrons there are. So if I had 1 electron, it would fill in the first energy level, the S sublevel, and there would be 1 electron. If I had a second electron, because I know that only 2 electrons can go in the S sublevel, it would still be in the first energy level, the S sublevel, and there would be 2 electrons. Also from the ChemQuest, you learned that the S sublevel starts at the first energy level. The P's don't start until the second. So the third electron would fill into the 2s sublevel. Okay, so in total I'd have 2 electrons in the 1s, 1 electron in the 2s, which would be a total of 3 electrons. Again, the last electron would be in the second energy level, S sublevel, and there'd be 1 electron there. So watch as I continue to fill in these electrons. The fourth one would become 2s2, and then I would go over into the P's. I know that the P's start at the second energy level, and I can have a total of 6 electrons go in there. There's no coincidence, okay, it's not a coincidence that there are 6 elements in that P subblock. As you can see, I fill all the way into 2p6. Next thing I'll do is head to the 3 S's, 3s1, 3s2, and then I'll go over into the 3 P's. Now just to make it a little bit easier, I've started to draw arrows, but you know that that means 3p1, 3p2, 3p3, and so on, all the way to 3p6. Okay, it's very standard up until this point. So I go 4s1, 4s2, and then one thing that you should have gotten from your ChemQuest is that the D sublevel starts at the third energy level. And unfortunately at this point we don't have a very good reason for it, but we know that electrons fill in the lowest energy level possible. Okay, the lowest energy it takes for them to exist in that spot. And for whatever reason, it actually is less energy for electrons to exist in the 4s than it is in the 3d. And that's why our periodic table is structured as it is. But unfortunately, what you have to remember is that in that fourth energy level, for the D sublevel, everything is shifted down. So that first electron that goes in there is in 3D1. And that will go all the way to 3D10. And once it's at 3D10, we'll go back into our 4Ps. So the S sublevel and the P sublevel are very standard. They go 1, 2, 3, 4, 5, 6, 7, and then unfortunately the Ds start at level 3. And that's really all you have to remember. So if you see, I'm just going to speed this up a little bit and finish up the electron configuration. You can pause at any time you need to fill in a blank periodic table if you'd like. Okay. Now notice again, this would continue down now into the F block. But remember I told you it was not necessary for you to know anything in the F block. So right now I've shown you how we look at the periodic table, but I haven't actually showed you how to write an electron configuration based off of the periodic table. That part is really easy. All you have to do is pick an element. And it doesn't matter, I know I have a blank periodic table right here. It doesn't matter which element I pick. So I'm just going to randomly circle one. And I picked that one right there at 3s2. So how I'm going to do this is I'm going to follow my finger, and as I pass each of these sublevels, I'm going to write down what I pass. So for example, I'm going to go 1s2, 2s2, 2p6, and then 3s2. Okay? And that's all I have to do. So in order to get to that spot, I had to pass 1s2, 2s2, 2p6, 3s2. Hopefully you find that a little bit easier. Let's do one more. Let's say I pick what I'm circling there in peach. Okay, again, a random element. I'm going to start with 1s2. There's nothing else over here, so I go straight to 2s2. Go to 2p6. 3s2. I pass 3p6. 4s2. Then I go to my 3Ds, so 3D10. And then for the last one, I just do 4P, and I go 1, 1, 2, 3. And that's why it becomes 4P3. The other nice thing about this is that in order to figure out if I want to look at if I look at an electron configuration that's already made, all I have to do is look at that very last number and letter combination, and as long as I understand what the periodic table of elements looks like and how the electron configuration works, I don't need to add up any electrons. So I can just say, well, this one is 3s2, so there's my third energy level, and it's going to be that second one. For the next one there, I'd go to 4p's, which starts right here, and I'd go 4p, 1, 2, 3, so it's whatever element is right there. So it also makes it easier to figure out what element has which electron configuration.